Hey everyone, today I will be doing a tutorial on this question right here. In this question, we're asked to find the related VO in the circuit below and the VS and specify the linear range VS and assume that VO is equal to 6 volts. So VO, the VO they're talking about here is actually V0. Sorry, this is V0 and V0 is equal to 6 volts. And we're going to call this right here VI, as in V initial. So let's do this. So what you want to do is you actually want to do a node voltage method at this node right here. And so what you will come up with should be, since V0 is equal to 6 volts, that means Vn should be also equal to 6 volts, right? And so another thing you need to keep in mind is that basically V0 is the same thing as Vn. So what you end up doing is you take V0 minus Vs right here. Oh, this is KCL, I guess, node voltage method. And you're finding the current through here. So VO minus Vs over 2 kilo ohms. And you're trying to find Vs, keep in mind, plus, which actually, let me move all this stuff down here. Let me move it a bit down. Move this down to Vs. Okay, so you do that. You do it for the 3 volts. Vn minus 3 volts over 4 kilo ohms. You do plus Vn minus 4 volts over 8 kilo ohms. And then, so you got everything on this part of the circuit, but what you need to keep in mind is you also need this right here. So what you'll end up doing is you'll put, you'll actually, since it tells you that this right here, this voltage right here is 16 volts is what you need to remember. So V initial in this is actually equal to 16 volts. And since it's VCC, it could either be positive or negative. So that is actually going to give us our range. So we need to keep that in mind. So we actually need to compute for both of the following, a positive and a negative 16. And so you Vn minus V initial over 8 kilo ohms, I believe. Yes, 8 kilo ohms. And so your range, whenever you solve, it should look something along the lines of the following. For V, whenever V initial is equal to 16 volts, positive 16 volts, Vs should be 5.5 volts. And whenever it's negative 16, it should be 13.5 volts. Sorry, not negative. Let me erase that, rewrite that. And so it should be less than or equal to V of S. So less than or equal. And this is your range right here. So that answers part A. Part B says determine the I0, I initial, so the current flowing through this entire part of the circuit. So what you'll need to do is find the current flowing through here and here, I believe. And so it says flowing into the op amp in the circuit under the conditions that V of S, which they specify this time around. Let me say this is A. So V of S is 0.5 and V0 is 0 and RL is 10 kilo ohms. So we go ahead and do the following. So we basically end up writing the whole thing all over again. So we go V0 minus they said 0.5 volts for the V of S, so we're just going to copy the equations over 2 kilo ohms plus V of N minus 3 volts over 4 kilo ohms plus Vn minus 4 volts over 8 kilo ohms. And then since they actually don't specify V initial, oh, actually, hold on. Sorry about that. Vn minus V0. Oh, sorry, it's not supposed to be Vn. It's supposed to be V initial. Sorry, V0, not initial. V0 minus V initial, which this time around you actually have to find V initial, right? So you go V initial minus V N, which is also V0, over 8 kilo ohms plus V initial divided by 10 kilo ohms. And that should give you whenever you insert this equation into the following into your calculator, it should give you something along the lines of, let me do the calculations real quick. And okay, sorry, let me just give you the equation for I0 real quick, I initial. So it should look something along the lines of this, where you go V0 minus VI over 8 kilo ohms plus you get the RL, which is 10 kilo ohms. Yeah, so it's gonna be VI over RL, VI over RL, which should be 10 kilo ohms, sorry, 10 kilo ohms. And let's calculate the following values. This is KCL. Remember, this is part B. We do that real quick. X minus Y over 3 plus Y over 10 times 10 to the power of 3. We got that down. Give me 1 second, we're almost there. We almost have the equation, or value, sorry. 0.5, and then that's that should be V0, which is X minus 3 over 4 times 10 to the power of 3 minus 4 over 8 times 10 to the power of 3, and then plus. Sorry, give me 1 second. I'm almost there. We have the values right here. Just takes a second to put those values into the calculator, and so it is going to be so these are the values right here. VI is actually going to equal 0.30 volts, whereas V0 is going to equal 1.5 volts. And whenever you input that into the following equation that I've given, you should get something along the lines of 1.5 minus 0.30, and then divided by 8 times 10 to the power of 3, plus VI, which is 0.30, over 10 times 10 to the power of 3. And you get the following value. You get IO is actually equal to 1.8 milliamperes. Thank you. Thank you for watching my tutorial. My name is Syed Yazan. Thank you.